This video is about transforming functions. So we know that if we have y equals x squared, we have a nice parabola. But what happens if we have y equals negative x squared? Well, that means every single y value that we had becomes negative. So if you think about that, here we have the point 0, 0, so it's a negative 0. We could build a table. Here we have the point 1, 1. So if you plug in 1 for x, you get negative 1 for y. We have the point 2, 4. If you plug in 2 for x, you get negative 4 for y. If you plug in negative 1, you get negative. And so if you, as you can see, this turns the whole graph upside down. So when we look at this, we talked last time about x minus h squared plus k, whether that's absolute value, squared, square root, whatever. What we're going to look at this time is the number in front of it, a. If the number a is a positive value, then the graph is normal or up. We say up, but that could mean normal because, you know, x to the third is the graph that looks like this, and it's up. And x to the 1/3 looks like this, and that's technically up or normal. So if a is negative, then we're going to say that that graph opens down. Now, it's easy to see down when we talk about this parabola here, but it means reflected across the x-axis. So that means it's going to reflect, it's going to flip over the x-axis, that mirror quality. So if I had, let's look at the next one. If I had y equals negative x to the third, well, x to the third looks like this. It's this tall graph. So if it reflects across the x-axis, that means instead of going up like this, it's going to go down. And instead of going down or heading up on this side, it's down. So this graph reads down instead of up. You can see how it reflects across the x-axis right here because that's what it causes right there. So the graph of y equals negative x to the third, I missed it, let me try again. The graph of y equals negative x to the third swings down like this. So a positive x to the third or a positive anything, when a is positive, it opens up or normal. And when a is negative, it reflects across the x-axis. And for our square root and our parabola and our absolute value, we can say that that opens down. So this reflects across the x-axis. All right, now let's talk about, there could be numbers here for a. So let's go back to y equals a parentheses x minus h squared plus k. Well, it could be a absolute value of x minus h plus k. It could be a times x minus h to the third plus k. It could be y equals a times the square root of x minus h plus k, and so forth. This a, we've already talked about positive or negative. So let's talk about numbers. If a is greater than 1, then this, I like to call it skinny. We're going to say stretched. Stretched is the correct mathematical word. And what happens is it makes it skinny. So if you have y equals x squared, your nice pretty parabola that we talk about all the time. If you put the number 2 in front of it, y equals 2x squared, then that means you take all of your y values for x squared and then multiply it by 2. So it stretches it up, it pulls it up into a skinny value. So if a is greater than 1, then this value is stretched. So what happens if a is less than 1? Let me get some space on here. So if a is less than 1, this is compressed or pushed down. So if we say y equals x squared, we have our nice parabola as usual. But if we say y equals 1/4 x squared, that means you're going to take all of your y values when normally when x is 2, y is 4. But in this case, when x is 2, 1/4 of that would be 1. So it stretches it out like this, and it pushes it down, and we call it compressed. So if a is greater than 1, we're stretched. If a is less than 1, we're compressed. If a equals 1, it's normal. So if there's nothing in front of the parentheses or the absolute value or the square root, it's our normal understood graph. So this is your note. If A is positive, it opens up or normal. If A is negative, it reflects across the x-axis or opens down. If A is greater than 1, it's stretched. If A is less than 1, it's compressed. And if A equals 1, it's normal. So let's look at a couple of examples. Let's say y equals 3 times x minus 4 squared plus 7. So first of all, our vertex is 4, 7. Keep the 4. Change the sign of the 4. Keep the 7. And then A is positive 3. The positive says it's up, and the 3 says it's stretched. So that means we have a graph. It's a U-shaped graph because the squared makes it a U-shaped graph. And then we're going to go over 4 and up 7. We're going to have a nice skinny graph. So if it's a sketch, you should label your vertex and write stretched somewhere on your paper. Okay? Let's say y equals negative 1/2 times the absolute value of x minus 3 minus 5. So we do have a vertex here. So our vertex is at, change the sign of h to be positive 3, keep the sign of k to be negative 5, and then a equals negative 1/2. So the negative says it's reflected or it's down. Either word is going to work. And the 1/2 says it's going to be compressed. I like to call it fat or squished. Any of those words work, as long as you figure out what you're supposed to be talking about. So here I'm going to go 3, negative 5, and it's going to be a fat upside down absolute value. I hope this makes sense. I hope you understand, and have a great day.